Going live. Come on, go live and live. Excellent. So for those of us joining us online and those of us joining us in the classroom, let me give you a little heads up as to what's going on. First and foremost, there are 2 assignments due at the end of this week. I'm not going to be assigning anything other than these 2 assignments. The first assignment is the project, which I assigned you guys last week. So you've had a week so far, but you still have the rest of this week as well, being due on Friday. And then there is also an Edge Elastic assignment, which again is not due until Friday. So you have a lot of time to get that thing done. You can consider those your enrichment activities for the week. So tomorrow, when you're not doing algebra or not doing an Algebra 2 live stream because you've already had the lesson, you would then work on those 2 things if you haven't done so already. Several people have already submitted the Edge Elastic thing. I think there's like 1 or 2 actually, just 1 or 2 total that have actually submitted anything on the project. But of course, like I said, you've already had a week, but you do have the rest of this week to get that stuff done. Next week, as I mentioned, because of the benchmark snafu, and again, the assignment will be there. That'll be a next week thing. But again, the benchmark doesn't count against you, because I know, like, you were taking the benchmark, you were like, well, this is a terrible benchmark, but you did it and you got credit for doing it. That's what matters. And that's next week though. This week we're focusing on the project. We're focusing on the Edge Elastic assignment. All of the instructions are in Google Classroom. Yay! Cool. You know what's so crazy about Wednesday? Wednesday the 7th. Do you know? Progress reports are due. Nope, Wednesday. I know that messed up already. Do you know what progress reports means? Progress reports means we've hit the halfway point in the marking period. What percentage, ready for this? What percentage of a school year is 1 marking period? A quarter, and then half a marking period would be an 1/8. Because of benchmarks, because of progress reports being due on Wednesday, that is 12.5% of the school year done. Isn't that nuts? It is still a lot more, yeah, but if you're downloading something or if you're doing like an update for something on the computer and you've gotten all the way up to 12% and it felt like it went by like that. Whatever. Maybe it's feeling like that way for you because you guys are only coming 2 days a week? Yeah. Just the Fridays? Okay. That's fine. So, as for today. Oh, as a reminder, I did put out on Friday on the stream in Google Classroom a 20-minute video explaining the problems from page 242. Take an opportunity and look at that video. If you had a question in regards to, I didn't know how to do this one problem, or I needed an explanation on this problem, I made a video explaining all of it. So please, by all means, check that out if you get the opportunity, especially in preparation for the Edge Elastic assessment and the project. But as for today, we're taking a slight step sideways. And I say sideways because we're not technically moving forward. Moving forward means we would be moving away from solving quadratics, but we're not moving away from solving quadratics. Instead, we are moving sideways towards a slightly different technique to solving quadratics. This is going to be separate from factoring, but it's still going to be the same concept, solving quadratics. Now, just as a verbal reminder, when I say solve a quadratic, if I say find me the solution to that quadratic, what are you actually looking for? Be more specific. X what? X squared? No. You're on the right track. I know what you're thinking of. Because I called the solutions 4 different things, and one of them had to do with that X. 4 different things. I called them solutions. I called them roots. I called them zeros. I called them X. Getting closer. X-intercepts. X-intercepts, yes. X-intercepts. Solving a quadratic means to find the x-intercept. Now, here is just a random quadratic. Now, let me show you what I've done here because this is phenomenal. What this is right here. I've put up the basic equation for a quadratic, y equals ax squared plus bx plus c. And I have these three things right here, which are what they call sliders. They call them sliders. Because what they do is I can slide these in either direction and change the a value to be any number between -10 and 10. I could do the same thing for B and the same thing for C. And they have little play buttons here, so if I play them, it'll actually automatically go back and forth. I'll show you that in a minute. But then I've done this little calculation as well. Now, this little calculation may or may not look familiar. If it doesn't look familiar, that's okay. After today, you'll understand what it means. But right now, just looking at this particular quadratic, could you tell me, based on our solution conversation, can you tell me what the solutions are? What is the solution to this quadratic? What is the 0? What is the root? What is the x-intercept to that quadratic? It's an easier answer than you think. It's not exactly 1. Now remember, he said x-axis, he said x-intercepts, right? What crosses the x-axis? Where does this graph cross the x-axis? You're shaking your head. Why? Don't say 0, though. 0 would be a number. But the other phrase that you said it doesn't. And I agree. This particular quadratic, this quadratic that I have in blue right here, this quadratic would have no real solutions. It would have what they call no real solutions. I want to be very clear about that. Now, I'm specifying that as real because that's going to come back next week. You'll see. It will come back next week. But for right now, the best we can say is this thing has no real solutions. But I can change a bunch of stuff. Watch this. Now, I'm just going to change the a value. Now, right now, actually, let me come back up here real quick. Right now, the a, b, and c, are all set to 1. They're all set to 1, which means this particular equation is y equals 1x squared plus 1x plus 1. That's what this equation is at the moment, just at the moment. It's 1x squared plus 1x plus 1. But let me change something. Let me change something here. Watch this. Now, all of a sudden, if I were to change, let's say, the a value, if I make that a value bigger, you can see what happens to the shape of that quadratic. Now, let me go the other direction. That's the more interesting thing. If I go the other direction, if I go towards the negative numbers, look what happens to the quadratic. What did it basically do from the first image that I showed you? Yeah, heck yeah. But now tell me, does it cross the x-axis? Yes, it does. Now, this particular quadratic would have 2 real solutions because it crosses the x-axis here and here. Now, again, let me move it again. This one, nope. This one, yes. This one, no. This one, yes. It's very weird. Let me put it back to 1. That's a 0. There it is, back at 1. Let me change the c value. Watch the c value. If I change the c value, what is the quadratic technically doing, if you could describe it? Coming up and down. In geometry, did you, now again, not to give you guys PTSD about geometry, okay? Not to change, do that about geometry. But when I did this, you said it flipped. Do you know the geometry term? It reflected. Yes, it reflected. When I changed that a value to be negative, it definitely reflected. But then when I'm changing the c value, you see it just kind of moving. Do you know the geometry term for that? Ah, yes. Anybody else get that? Remember that? Kind of, maybe, yeah. You also refer to it as a translation is the actual term. Yes, it is. They've also called it a slide because literally you're just sliding it back and forth. But again, originally I had the C value at 1. But if I slide it down, all of a sudden, oh, looky there, now it actually crosses the x-axis. You can change these values to be anything. Now look at this. This is the coolest thing, the B value. Check this out. I'm going to change the B value. Now, can you all see that giant blue dot in the middle? Right there. Check this out. Check this out. Look at this thing move. The B value. The A, the B, and the C all work together towards what answer this particular equation is supposed to have. The A, the B, and the C all work together to get a specific answer. It's not just one number or the other. And this should make a little sense because if you think back to the Tucker method, step 3 of the Tucker method of factoring was to find 2 magic numbers. What did those 2 magic numbers have to do? Step 1, you take out the GCF. Step 2, you multiply A times C. Step 3, you had to find me 2 magic numbers. 2 magic numbers that multiplied to A times C, and at the exact same moment, they had to add up to the B value. If you change anything in the equation, it affects what the answer is supposed to be. Let me pause that there. Let me see if I can I do all 3 at the same time? Oh, that's awesome. Look at that. I love Desmos so much. Anyway, pause that, pause that, pause that. Now, let me go back to an example that we did. There we go. Here we go. This is one of the original problems that I showed you when I started this whole thing, probably like 2 weeks ago, maybe 3 weeks ago. I can't even remember. This equation, if you look at the value of A, the value of B, and the value of C, this is the equation y equals x squared plus x minus 6. I changed the A, the B, and the C to do that. You can factor this. You can factor this. You can factor this into x plus 3 and x minus 2. That is factorable. It is factorable. Tell me, what would my solutions be from that? If I had to find the solutions, if I had to find the zeros of the function, what value of x would cross the x-axis? What value of x would cross the x-axis here? You can either get it from the equation or you can get it from the actual graph itself. Give me a number. I hear crickets or something along those lines. Just tell me, what number does it cross the x-axis at? Oh, Ms. Berger, it's clearly a 2. Oh, good job, whoever said that. Pat myself on the back. Look, it crosses at 2, positive 2. X minus 2 equals 0. Set that equal to 0, solve. You get x equals 2. What's the other number? Negative 3. Yes, we did it. Now, that's reviewing the Tucker method. I want to show you something. I want to show you something. Look at this calculation down here. I have not said anything about this calculation other than we'll get used to it today. But what this calculation does is it takes the value of A, it takes the value of B, and it takes the value of C, in this case, negative 6, and it does this calculation, B squared minus 4AC, and it gives you a number down here. What's so special about that number? What is so special about the number 25? Ooh. Let me show you another one. Now, I'm going to come back to that question. I'm going to ask you what's so special about the b squared minus 4ac, but let me just show you another example here. Let's see. I'll do change this to a 2, and I'll change this to a -1, and you know what? I'll keep it there. I will keep it exactly right there. Get rid of that. Now, this equation that I have changed it to, I have changed it to a y equals 2x squared minus x minus 6. And this is indeed factorable. It is what we call factorable. And the two answers that we actually end up getting are nice looking answers. They are nice looking answers, one here being click, click, one being +2 and the other one being -1.5. What do you notice about the b squared minus 4ac? And this number right here. Before it was a 25. Now it's a 49. There should be kind of gears turning in your brain right now based on some stuff that you did back in like 4th and 5th grade. Something about those numbers, 25 and 49. Let me show you one more. Let me show you one more. Let me change this to a 4. Let's change that to a 0. And let's change that to a -9. There we go. Now the equation that I have here is really messed up. It's y equals 4x squared. Now, mind you, the b value is 0, so I'm not going to write it, but -9. That's factorable. The two answers that actually pop up right here are the answers +1.5 and -1.5. That's actually what you're finding when you factored it, which, as a side note, it would factor into 2x minus 3, 2x plus 3, which would produce those two answers. But what do you notice about the b squared minus 4ac? First, it was a 25, then it was a 49, then it was a 144. Yeah, positive perfect square. I want to be clear about that because something's about to happen here. Now, I'm going to go back to a previous example, but keep that in mind. If this number is a positive perfect square, then the quadratic is factorable. Factorable. I'm going to change some numbers around. I'm actually just going to change a couple numbers around. Let me change it back to a 2, a -1, and it was a -6. We had these answers right here. We had the answers of -1.5 and +2, which is fantastic. But now let me change the 6. Watch very carefully. Watch what happens to the quadratic. Watch what happens as I'm sliding this thing forward. Now look at the, actually I'm going to circle it on the board. Watch what's happening to the quadratic and watch what's happening to this number right here. Look what's happening to that number right there. As I change the value of this quadratic. Slide. What are my x-intercepts? He's shaking his head no. Why? Well, what are my x-intercepts, though? Answer that question first. Where does it cross the x-axis? It doesn't. And what's the b squared minus 4ac? Now it's a negative number, though. Now it's a negative number. Now it's a negative number. If I slide this thing back down a little bit more, now all of a sudden, now that I've slid it back down, now that this thing actually does cross the x-axis, it has a solution, and this number is back to being positive. Furthermore, what's that number? perfect square, which means, oh, holy crap, hold on. Since that number's a perfect square, what equation do I have? I have a 2x squared minus x minus 1. You're telling me that that is factorable? Let's see what happens. A times c is -2. Two magic numbers are -2 and +1. T chart, 2x and 2x, -2 and 1. 1, x minus 1, 2x plus 1. That one's factorable. There's something that I'm aiming at, ladies and gentlemen. There's something that I'm aiming at. This is what I'm aiming at for today. Back near the end of Algebra 1, you were presented with a formula that either you don't remember because you blocked it out of your memory, or because it scared you too much, or you have vague memories of what it looks like. But it includes this little calculation of b squared minus 4ac. And this is what I want to walk you through today. Now, we're going to come back to this Desmos in a little bit, but ladies and gentlemen, in the meantime, if you do not already have them out, I'm going to need those notebooks out and open. Oh, no, I needed that. Duplicates. Bring that one up. There we go. Bum, 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 bum. Today is October 5th. I'm going to solve quadratics by quad formula. Now, again, you may have been introduced to this once in your life, but I guarantee you it's probably near the end of Algebra 1. It was 2 or 3 years ago for some of you. And it was just one of those things where you're just like, oh my gosh, when am I ever going to, oh my gosh, this is the disgusting formula. I know. We'll deal with it. First, the quad equation that we're typically given is this: ax squared plus bx plus c equals 0. That is the quad equation. That is not the formula. That is not the formula. That is the equation. This equation is where you would identify the values of a, b, and c. This is where you would identify the values of a, b, and c. And I want to reiterate something very important to you. What does this equation equal? Yes, just like factoring. Just like factoring, the equation has to be equal to 0. I need to emphasize that. Because if it's not equal to 0, then it is not going to work properly. Make sure it's equal to 0. Furthermore, there is something called the discriminant. There is a calculation called the discriminant. I'm going to abbreviate it to DISC. I'm going to abbreviate it to DISC, DISC. But this discriminant can be calculated using the values of b squared minus 4ac. Now, when I say b squared minus 4ac, that might remind you as to what the entire formula looks like, but we'll get there in a little bit. Couple of if-then statements. If discriminant is greater than 0, then two real solutions. If the value of your discriminant, and I am going to go back to Desmos in a few minutes. But if the value of your discriminant is greater than 0, then your equation will have two real solutions. If the discriminant is equal to 0, which is a very, very, very special case, then you will have one real solution. Just one. And I will show you that. But as I tried to show you on Desmos, if the discriminant is less than 0, meaning the discriminant is a negative number, if it is a negative number, do you remember how many real solutions we actually got? You could even look at the pattern of the then statements that I have and take a guess at it. How many real solutions should we have if the discriminant's negative? Yeah, you should have none. Then you could say no real solutions. Now, I want to emphasize something here. I want to emphasize something very important that's going to come back and haunt you. I say no real solutions. Now, I'm going to ask a question about Algebra 1. I have no idea what happened because I haven't taught Algebra 1 in like 8 years. So I have no idea whether or not they actually do this. Did you guys ever learn the opposite of real numbers in math? What about the words complex numbers? Maybe. What about imaginary numbers? You have? No? Oh, you have. Ooh. Now, imaginary is a terrible name. Imaginary is a terrible name because guess what? They exist. They exist. Mathematicians called it imaginary because they didn't like it. But they exist. But that's not this lesson. That is not this lesson. Right now, for this lesson, if your discriminant is less than 0, then you will say, for the time being, no real solutions. You would say no real, implying that there are other types of solutions. So please keep that in mind. But for now, this is where we're at. Let me go back to Desmos. Chapow. Let me give you this one. Nope, not that one. Crikey. That one, and that one, and that one. There we go. Look at that. Look at that one. Let me write this one up on the board. Look at this junk. This is the equation y equals x squared plus 6x plus 9. And look at the value of the discriminant. I did this on purpose. The value of the discriminant is 0, which means according to your notes, if the discriminant is equal to 0, then how many real solutions do you have? You just have one real solution. Watch what happens. Watch what happens here. If I were to factor this, a times c would be 9. Can you give me two numbers that multiply to 9 and add up to 6? 3 and 3. Which would become x plus 3, meaning I get -3 and -3. Wait, I get -3 twice. How is that even possible? Well, technically it's not. So the only thing you would say, and I tried to highlight it there. You can see it right there. It's just the one dot. You only have one real solution. One real solution. There's a reason for it. Oh my, there's a reason for it. And here it comes. Ladies and gentlemen, I'll go back to my notes real quick and write this down. This is the quad formula. X equals. It's a big old fraction. Negative b plus or minus. Look how I wrote that plus or minus. And again, some of you may or may not be familiar with this from Algebra 1. A big old square root. B squared minus 4AC. That's the discriminant that we were just talking about. And the whole thing is over 2A. This is an alternate way to solve quadratics. I'm going to put a little note here. A star, if you will. Whenever I won't put that many stars in your notes. I'm not going to put stars everywhere like I'm in middle school, you know, like something. I don't know. I don't know what middle school does. Middle schoolers are like animals to me. But when I put a star, you better believe it's important. If you cannot solve by factoring, the quad formula will always work. If you cannot solve by factoring, meaning it was not factorable, then the quad formula will always work. It just will. Now, let me go back to Desmos real quick. And I'm going to do something here. Check this junk out, what I'm about to do. Let's see. Copy and paste and minus. Here we go. Get rid of that. Perfect. Okay. Look what I just did here. I very quickly typed in the equation, or I'm sorry, the quadratic formula twice. But notice the difference right here. Notice the difference. I did one with plus, I did one with minus. Because when you have that plus or minus, you are going to get two different solutions. Or theoretically, you should get two different solutions. Sometimes they'll be the same solution, like this one right here. Let me go a little bit farther. Let me go back to one of the examples we did before. One of the examples we did before was that. One of the examples we did before was that. It was a 1x squared. Bring this marker out right here. Where'd you go, marker? There you are. I don't want this marker. Whatever. This was x squared plus x minus 6. And you can see where it crosses on the x-axis, and you can see what the formula has done with the two different answers. Now let me slide this thing up. Watch this. Watch this. Watch this. I'm going to slide this thing up. Oh, not the b value. Come on, b value. There you go. Here's the c value. Look at the c value. Now tell me, right where my mouse is, am I still getting two different solutions? Yeah, still getting two different solutions. Let me slide it up more. Still getting two different solutions, still crossing the x-axis twice. Chapow! Undefined. No real solutions. Here's the big question. Here's the big question. Why? Yes, you can visibly see it does not cross the x-axis. Yes, I can see that. It doesn't cross the x-axis. There's something in this formula. There is something in this formula that is forcing it to be undefined. There's two specific things in here that could happen. There are two specific things in here that you learned years ago, middle school, elementary school. There are things in math that you can't do, otherwise your calculator would say error. Name one of those things. What's something in math that you can't calculate because if you did, your calculator would say error? Dividing by zero. Dividing by zero, definitely it would say error and it would be undefined. Now, here's the beauty of this formula. The beauty of this formula, ax squared plus bx plus c, is the only way that it's going to be dividing by zero is if that a value were zero, which for a quadratic, it will never be zero. For a quadratic, it'll never be zero. Watch what happens when my a value is zero. Watch what happens when my a value is zero. Is that a quadratic? What is it? It's not a quadratic. Go back to Algebra 1. Go back to middle school. What is that? No one wants to say it, Mr. Markey. We're all afraid to. Because too much time has gone by with no one answering. It's a straight line. What's the other thing you're not allowed to do? You're not allowed to divide by zero. I agree. What's the other thing you're not allowed to do? Otherwise, you get an error in your calculator. Ooh. What's the square root of 25? Square root of 25. 5. What's square root of 49? 7. Why is the square root of 49 7? Why? Just why? 7 times 7. Yes, I agree with you wholeheartedly. I agree. Square root of 100 is 10. Square root of 81 is 9. What's the square root of negative 4? What's the square root of negative 4? Say again? There's none in the real answers. You can't say 2, because what 2 times 2 is 4. You can't say negative 2, because negative 2 times negative 2 is 4. You can't take the square root of a negative. Let me repeat that with a little extra. You can't take the square root of a negative for now. For now. But if the b squared minus 4ac is negative, you're supposed to get no real solutions. And the b squared minus 4ac is underneath the square root. The square root of a negative produces an undefined answer, which is why there's no real solutions up there. There's no x-intercepts on that graph. This whole thing is interconnected. Have you ever met someone who is very susceptible to conspiracy theories? Right? My father-in-law is one of those. Very susceptible. Like, you ever see like the streaks of smoke in the air? Chemtrails? You know what I'm talking about? Like stuff like that. Completely believes in chemtrails. Completely believes they're brainwashing us through the fluoride in the water supply. Yeah, just gotta fill up pass. My point is that in mathematics, it is like, here, fill this right there. It is like one giant conspiracy theory. Everything is connected. Everything lays on top of itself. Everything supports itself. It's insane how much connection this thing has between the graph and between factoring and between everything else that we have in this problem. It's going to be amazing. Here, I'm going to borrow these papers right here. There you go. I'm going to give you a piece of paper. We're going to work on some problems. I'll give you these. There's 3. For those of you in the live stream, I'm going to be posting the PDF. Here. I'm going to be posting the PDF of the worksheet that I just passed out in just a moment. Sitting back down and doing that right now. So if you want to follow along with the problems that we are doing, they are right there in PDF form directly on the Google Stream. Let's see what we got. Now, looking at that worksheet, there's a whole slew of problems floating around. Oh, there we are. There's a whole slew of problems just floating around that worksheet. Let's take a look at a couple of them and see what we can do with it. And I'll show you what you can do. First, zooming in, zooming in, zooming in, zooming in, zooming in, zooming in. Let's take a look. Zoom. At number 6. Let's take a look at number 6. And I'm moving this over to the side because I'm going to put my work directly on this worksheet. Let's see what this does. Now, first of all, I'm going to have to do this first, ladies and gentlemen. If you're going to use the quadratic formula, you're going to need one side of that equation equal to 0. You're going to need one side of that equation equal to 0. Please make sure it's equal to 0. Just like factoring, it's not going to work if you do it that way. Now, let's calculate, and I'll do this with you. You'll see. I'll do this with you. Let's calculate the b squared minus 4ac separately. Sometimes it's a good idea to calculate this thing separately. I'll show you what it looks like in a moment. There we go. Here we go. Now, if you notice, again, it says b squared, which is 22 squared, minus 4ac. The a and the c are 15 and 8. If I calculate that, you can see it gets you a 4 right on the dot. The b squared minus 4ac gets you a 4 right on the dot. Now, I may have said this before, but I'm going to say it again, and I'm going to say it again throughout the entire school year. Parentheses will save your life. Have I said that before? No? You know why parentheses will save your life? There's a couple reasons. Number one, if you're squaring a negative, you better be using parentheses with that negative on the inside. But also parentheses, if you look at a set of parentheses, they just look like a big hug. And sometimes hugs can save your life. It's like a lifesaver. Back to this. B squared minus 4ac got me a positive 4. Then I'm going to go after the quadratic formula. Now, again, I'm going to go into my notes with a different problem in a little bit, one that I need a little bit more space for. But this one, I'm going to have to do a negative b, which in this case is a negative 22, plus or minus the square root. Now, inside of that square root is supposed to be b squared minus 4ac, but I've already calculated it. So I'm just going to put it there. Now, yes, I can take the square root of 4, which I will in a little bit. Not at the moment. We're going to leave it be for the moment. But the whole thing is over 2 times a, which in this case is 2 times 15. You need to clearly identify the values of a, b, and c in regards to the quadratic equation. Ax squared plus bx plus c. Now, I cannot leave my answer like this. I will not leave my answer like this. That didn't make any sense. Instead, let me do this. Equals negative 22 plus or minus 2 over 30. I'm not done yet. I am not done yet. but I just need you to see what I've done so far. I've plugged in the numbers into the appropriate location. I evaluated the negative times 22. That was easy. I evaluated on the bottom of the fraction 2 times 15. That was 30. I evaluated the square root of 4. It just became 2. This is actually one of the bigger mistakes that people make when they evaluate the square root of 4. They make it a 2, but they leave the square root there. But when you evaluate the square root of 4, the square root goes away and becomes a 2. But I'm not done yet. See, the thing is, you have to deal with this plus or minus. Plus or minus, you are going to get 2 different answers, and you have to take both of them into account. I am going to have to evaluate this fraction once with the plus and once with the minus, and that will give me my 2 answers. This is exactly what you need to do. So you can write it out as, well, negative 22 plus 2 is negative 20 over 30, and negative 22 minus 2 is negative 24 over 30. I need to simplify that junk down. This would become a negative 2/3. And the other one would become a negative 4/5. If you simplified that correctly. You needed to evaluate the plus, then you needed to evaluate the minus. Now keep in mind those 2 fractions. Those 2 fractions look terrible. Those 2 fractions look terrible as answers, but they are our answers. They are. Watch this. Go back over here. Let me, I don't want that to animate. Can I change this to a, what was it, a 15? Can I change it to a 15? Will it let me? Oh my gosh, it will. All right, let me change that to 22. And let me change that to an 8. Now, first of all, oh my gosh, look at the bottom of the screen. This is the fraction negative 4 over 5. This is the fraction negative 2/3. Look how itty bitty tiny that is. Itty bitty tiny. It's so, you can actually zoom in and see it if you needed to, which is besides the point. It's the itty bitty fractions. There they are, negative 2/3, negative 4/5. Ladies and gentlemen, let's go back to our notes. Back to our notes. I have a few examples that I want to show you. Click, and then we'll jump back to this worksheet with the time that we have left. Zooming out, zooming out, zooming out. There we go. Give me a number, any number. I need a number. 7, okay. 7 should work. Good, let's do this one. Example. X squared plus 7x plus 12 equals 0. We're going to solve that. We're going to solve by quad formula. Now, with this problem, first, it's equal to 0, so you don't have to worry about that. I need the value of A, I need the value of B, I need the value of C. Now, you gave me 7, which I made the B value. What's the value of A for this problem? It is vital to get the correct answer. Yes. And the value of C? Ooh. Oh, someone get that? It's not 7. 7's the B value. As for the C value, that's okay. 12. Now, when you are doing this on your own, I strongly suggest calculate B squared minus 4AC separately. You don't have to. But it will make your life so much easier. Where you could calculate 7 squared minus 4 times 1 times 12, which would get you 49 minus 48, which equals positive 1. First of all, what type of number is 1? What type of number is 1? You guys have been dealing with 1 since like preschool, I think, right? It's the first number you ever started counting with. My daughter counts by 2s. So when we say 1, she just goes 2, 4, 6, 8. It's weird. What's so special about 1? Is it positive or negative? Positive. Is it a perfect square? Is it a perfect square? What's the square root of 1? Perfect square. Yeah, that's what I'm saying. A lot of people miss that. A lot of people miss that because they're just, 4, 9, 16, 25. They're used to those numbers, but they're not used to 1. 1 is a perfect square. Check this out now. Negative b plus or minus the square root of 1 divided by 2 times my a value. This is using the quad formula. You need to get used to it. You need to know how to use that formula. When I first mentioned the quad formula several weeks ago, I said it very quickly because I've done it so many times, it's ingrained in my brain. You need to know the structure of this formula. Negative 7 plus or minus 1 over 2. You're going to get 2 answers, but you have to evaluate them correctly. You're going to get 2 answers, but you have to evaluate them correctly. You're going to get negative 7 plus 1 over 2, which equals negative 3. And you're going to get negative 7 minus 1 over 2, which will get you negative 4. Now, again, I bring your attention back to what we did the past several weeks, where you could factor this into x plus 3, x plus 4, and you get 2 answers. Okay. Now I'm going to mess with your heads. Because this is going to be... Oh, that was just an example from Factor. I didn't want to put that into my notes. I was just kind of showing it. You want me to put it back? Okay. It wasn't necessary for the notes today, but this was. I'm going to mess with your heads, though. I love messing with your heads. Check this junk out. Hold on. Okay. Solve x squared minus x. Give me any single digit number, and I'll tell you if it works or not. Say again? I can't use 6. Oh, I can use either 8 or 3. Let's go with 3 since that was the first one I heard. I can't use 6, though. There's a reason why I can't use 6, but I'm going to do 3. Cool. Plus 3 equals 0. I'm so pumped for this problem. Can you tell? Oh, good. Guess how much coffee I've drunk? 2 ounces. That's like, you see this? It's like filled to that. I've drunk like that much. I'm hyped. All you're talking at once. It's like, what? All right, whatever. Maybe you guys are doing coffee wrong. Now, mind you, I'm not saying that this is all teenagers. Because you guys might be the exception to that rule. But when I see teenagers doing coffee at Wawa, I see them, they pour the coffee, right? They pour the coffee. Now, mind you, This is not open. Keep in mind, this is not open. But I've seen this is the sugar. So they pour the coffee, and then I see them do this. Then they get the flavored creamer, like hazelnut, and they're like, I'm just saying, I'm not saying all teenagers are like that, but I've seen way too many teenagers do that to their coffee. Yes, they are. I agree with you. Anyway. No, I agree with you wholeheartedly. Like, anyway, back to this. A value is 1. B value is, -1. -1. Make sure you realize it's a -1. I'm talking like I'm in an ASMR. And then C is 3. Now check this junk out. B squared minus 4AC. I've always told you to calculate it separately. Now check this out. -1 squared. Notice the -1 is in parentheses. Minus 4AC. I'm going to do this in my calculator. And you get parentheses, -1 parentheses squared, minus 4 times 1 times 3. And I get a discriminant of -11. Now tell me, what's your answer if you get a discriminant that is negative? There's the extra word. No real solutions. At this point in the problem, at this point, right now, as of only now, no real solutions. And you could even, now if you don't have to do this, but I'm going to put this additional note, because discriminant is less than 0. Answer this. Where does the discriminant go in the quadratic formula? Where does the discriminant go in the quadratic formula? In what thing? It's the square root. You knew what you were talking about. You did, but it goes in the square root. And look what happens to your calculator. I'm gonna zoom in. Look what happens to your calculator when you try to take the square root of -11. Chapow. Non-real answer. I'm going to show you non-real answers next week. But I want to do this problem again just by changing one thing. Check this out. Last problem of the day. We'll have to come back to the worksheet another time, but that worksheet is good practice. If you want good practice problems, that worksheet is right up your wheelhouse. But look at this. Let me change one thing. X squared minus x minus 3. Zooming out. Equals 0. Last problem today. What did I change? I changed one thing. I made it a -3. Now remember, I showed you that by changing the A value, the B value, or the C value could greatly affect what would happen to the answer. Changing one of those values would greatly affect what happens to the answer of this problem. I showed you that with Desmos, with sliding things around. In fact, check this out. Change this to 1, -1, and a -3. You can see right there, yes, I'm going to get 2 answers. But look at those things right down here. Look down here. Look at these 2 right here where my mouse is. That doesn't look nice. I'm going to show you a nice way of doing it. I'm going to show you a nice way of doing it. First of all, let's do b squared minus 4ac. B squared minus 4ac would give me the value of my discriminant, but we changed one number. We changed one number in this thing. Parentheses, -1 squared minus 4 times a times -3. All of a sudden, we got a positive discriminant. We got a positive discriminant. Positive, positive, positive. Meaning we should have 2 real solutions. Let's keep going, though. Let's get those solutions. -b, look how I'm writing this, plus or minus the square root of 13 divided by 2 times 1. Now look how I wrote that. Look how I wrote that. It's a negative b value. The b value is already -1. What happens, or what should happen if I did -1? What should happen? You guys ever learn, I don't know what grade it was, but they learned like keep, change, flip or some junk like that, or keep, change, change? You know what I'm talking about? Negative of negative is just a what? Just a positive, yeah. 1 plus or minus the square root of 13 over 2. Now, back in geometry. Or maybe even earlier. When you guys did Pythagorean theorem, you had to simplify square roots, didn't you? Yeah. So you are still going to have to simplify square roots if you can. Now, we are going to focus on simplifying square roots next week because of the nature of the square roots of negatives that I have to introduce to you. But look at this problem. The square root of 13 cannot be simplified. Now I'm going to show you something that you're either going to love or you're going to hate. You're either going to love what I'm about to do or you're going to absolutely hate what I'm about to do. You ready for this? That's our answer. You have 2 answers. You have 2 answers. You have one answer that is 1 plus the square root of 13, the whole thing over 2. And you have another answer, 1 minus the square root of 13, the whole thing over 2. But the square root of 13, well, you can't take the square root of 13. You can't simplify the square root of 13. And since you can't do anything with this, this is all that you can conceivably do. Now, if you wanted to, you could do this. Which you might see an answer looking like that. You might see it looking like that. 1 over 2 plus or minus the square root of 13 over 2. But in reality, what I've circled is just fine. Ladies and gentlemen, do not forget the things that you have due for me. If you need some extra help with factoring, there is a 20-minute video explaining the homework assignment on that Google Classroom stream. If you do have any questions, of course, you can email me directly and we can discuss those things. There's plenty of resources that I can point you towards. You have an Edulastic assessment due on Friday on factoring. You have a project due on Friday on factoring. And then we'll see where it goes from there. Anywho's, I'm going to sign off. And we're going to call it a day because the bell's going to ring in like 30 seconds. So have fun, everyone.